So the last example we're going to look at today is case study ex4, and this is going to demonstrate using the I/O scheduler in order to download and store images from remote web servers via Flowable and, most importantly, parallel Flowable operators. And of course, why this is significant is this is very similar to what you're doing for programming assignment 4B. And you'll see here that there's an example. This is in my ex4 project in the reactive Flowable folder in my GitHub Live Lessons repository that shows everything we're about to walk through. So we're now in the ex4 project. Let's go ahead and click on ex4. This is the main entry point. You can see here, as always, we're going to go ahead and register the method under test, which is called test parallel downloads, which uses a parallel Flowable to download and store the images from remote web servers in parallel. Again, as always, once we've registered with that with the async task pair, we run it, and then the main thread blocks till all the processing is done. Nothing different here. Let's take a look at parallel Flowable. You can see here that this is going to start by having the test parallel downloads method create a string builder that says what's being run, and it indicates what thread it's starting out in. And then we go ahead and we have the flow, the stream, if you will. And we do this by starting out by taking a list of URLs. And this list of URLs comes over here. This is just a list of image names. These image names are names from my website here at Vanderbilt. And we convert those into URLs up to some max size, which in this case is whatever we set it to be. I think it's 42. And then we create and return this as a list of URLs. And of course, we should probably be doing this as toList. Maybe we should not be doing it as toList. Well, oh, it wants it to be, yeah, I'll fix that later. So we go ahead and create ourselves a list of URLs. And that list of URLs is then turned into a Flowable, but that's a sequential Flowable, but we want a parallel Flowable. So of course, we use the parallel factor method to make a parallel Flowable. And now we're going to run all this processing that comes henceforth in the context of the I/O thread pool, which, as you recall, will create new threads if there aren't already threads in the cache, to do the blocking operations, because we're going to be doing blocking downloads. And then we use the map method, which works on parallel Flowable, to transform each of the URLs we got here from get URL list into basically, we're going to transform them from the URL into a file by downloading stuff. So download and store image is a method accessed by a method reference. And you can see what it does is it performs a blocking download, which we'll look at in a second. So it takes the URL, performs a blocking download, and when it's done, it's going to store the downloaded image onto the local device, which could be a phone, or in this case, it's just my laptop computer. Let's go take a look at download image. Here's download image. You can see that takes the URL, and it's going to call this download content method, which we'll look at in a second. And that's going to wrap up the content in an image object. Let's look at download content. Download content just goes ahead and opens up the URL. That's a method that's used to do a connection to the link you give here, the hyperlink, or the URL. It gives back an output stream, and then all we do is we just read from that output stream a chunk at a time, where a chunk is a 4K buffer. And we write that, we read from the input, which is the stream that's connected to the remote server. We write to our local O stream, which we created up here, a byte array output stream, and we read it into a buffer, and we just keep writing it till we're done. And when we're all done, we convert the output stream into a byte array. So now we've got a byte array that comes back. That's going to be stored in this image constructor. So you can see that just basically stashes that URL and the image data there, so we can do something with it. In this case, we don't really do anything with it other than keep track of its size, but we could do something more interesting like display it somewhere. So that's what download and store image does. You can see that that will be a fairly long-running operation, because we have to make a connection to the server, download the image, and then store the image. And store is just going to go ahead and write the image to the disk. Let's go look at that. So store makes a new file, and it takes the image file, the image that we have, and we go ahead and write the image file to the disk. So that gets written out, and you can see here how it does a write, and we're going to store it in PNG format. What the heck? I like that format. So that's what download and store image does. Then we go ahead and do a little debugging just to say what happened. We say what thread this occurred in, what the name of the file was that we created, what the length of the file was that we created. And now we convert this back into a sequential, flowable, print the results out from our string buffer. We can just print those results right here. And then the last sets of things we do is we collect the downloaded images into a list. So we had a flowable of basically, at this point, files. And we collect those things into a list that returns, I believe, perhaps a maybe to a list. And then if we were successful, if we didn't have an exception, we print the results out. You'll see what that does in a second. It just basically says how many images we downloaded. And then we return the completable saying we're done. And the system will go ahead and return from the main thread so we can exit the program gracefully. So let's go ahead and run this thing. This is actually going out and making a network connection to my server here at Vanderbilt. So it takes a little while to run because it has to go down and download a bunch of images. And you'll see as it's downloaded, it'll go ahead and print the results out. So you can see that we downloaded a bunch of images. And also take a careful look. You can see that these images are telling what thread they were downloaded in. And so you can see that it was obviously recycling some of the threads, like thread 23 gets used a couple places. I think it's used at least 3 places here, maybe more. But there's a bunch of threads that are being used for this. And then when we're finally all done, it prints out that we downloaded and stored 42 images. And ignore that. It used a bunch of threads in the thread pool. There's one left at the moment, but that's what it did when we ran it. Okay, so that is the end of that discussion, and that should be quite relevant because you're going to use most of those methods one way or another in assignment 4B. So this will give you a good sense of something akin to what you're doing. Obviously, your example is a little bit more sophisticated than this because you're downloading the images and applying image filters in parallel. So you'll be using we're going to be using more mechanisms in the assignment than we use in this simple example, but it shows you the basic flow of how the processing takes place.